Hi, this is Mrs. Slater, and today we're going to talk about how to go from radical to rational exponents and how to change from rational to radical. So let's begin by titling the first one. We'll go from radical form to rational exponent. Okay, now keep in mind what this means. It means we're going to have a fraction as an exponent. And this one, radical form, just means there's going to be a radical in the answer. So if you had the square root of 6, we have first just identify what numbers there are. This is saying that there's an invisible 2 and there's an invisible 1. So if you take that information, all you have to do is take the radicand, which is the 6, and then the exponent is going to be the exponent of the inside over the index. So the index is always going to be on the bottom. So another way to write square root of 6 is 6 to the 1/2. And again, this is all going to be for shortcuts later on in the homework assignment. All right, so another one that we can look at is cube root of 5. If we put all the invisible things that are not there, there would be a 1 there. And rational exponent would be 1 and over 3. 5 to the 1/3 is the exact same thing as cube root of 5. And then this one, I'll intensify the problem just a little bit here, which is the exact same thing as saying, again, you got all those that sometimes you have invisible exponents in there that you would want to write down. This is like saying 16 to the 1/7, x to the 4/7, y to the 3/7, and that would be in rational exponent form. Okay, now let's go in reverse. We're going to start with rational and then end in radical form. So 7 to the 3/4 is 7/3 inside the radical sign, and the 4 is going to be the index. 10a in parentheses to the 1/2 is another way to write it as 10 to the 1/2, a to the 1/2. We can do that with multiplication. And then if we're going to put it all under one radical, notice they both have the 2 as the index, so square rooted, the 2 is going to go on the outside, and then 10a is going to go on the inside with their invisible 1s. Now we know that this is the most simplified version because the 2 and the 1s can be invisible. And then finally, let's have one more of these. X to the 3/4, y to the 4/5 is a number that's in rational form. So this one would be 12 squared with the cube root. And actually, let's go ahead and we have to put it all under one radical. So what is a common factor or a common multiple they all have? 3, 4, and 5 all go into 20 times 3 is 60. Is that the lowest thing they all go into? I believe it is. So let's change so they all have the same denominator. So if this is going to go to 60, this would have to be 20. If this is 60, that is going to have to. So after calculating, I know I have to multiply this by 15 to get an answer of 45. And then if this is going to be 60, I have it calculated as well, which is going to be multiplied by 12, and then that would give you 48. So the reason I did this is so I could get everything under the same radical. So this would be 12 to the 40th, x to the 45th, and y to the 48th, all in the 60th root. Woo! So that's quite a challenge there, but that's how you can get it all under one radical. Next, we're going to rewrite numbers with positive exponents. On the first one, anything that's negative, as we've talked about before, is going to go in the denominator. So that's no different here. Okay, and then we're also going to simplify anything. So having that negative gone will help us with that. Changing that to a radical, now that we know how to change it into a radical, gives us a cube root of 8, which we know is 2. So we have just simplified it into 1/2. Next, 1 over 16 to the 3/4, which we know is 16 cubed inside the 4th root symbol. Okay? Now, if you look at this denominator, there are two things going on here. You can either say that it is the 4th root of 16, and then all of that's cubed, or you can do 14, and then do, or I'm sorry, the 4th root of 16, and do the 16/3 first. You'll get the exact same answer. Now, mentally, mental math, I can remember that that's 2, and 2 to the 3rd is 8. So I would go with 8. This one, 16 to the 3rd power, I'd have to get my calculator out for that one. So I chose the route where I didn't have to use my calculator. And I get an answer of 1/8. Okay, let's look at the next bunch of numbers. Simplify with rational exponents. So what I'm looking for here is the same base, which we have, and I'm going to add the exponents together. So that's going to give me 10/5, and I can simplify that rational exponent to 2 for a final answer of 4. So the value of that is 4. The next one, whenever you have the same base, you're going to subtract the exponents. So you get 5 to the 3/3, which we know is 5 to the 1st power, and we do not have to write that exponent, so it would be 5. And the next one, power to a power, we're going to multiply here. Multiply the exponents. So I get 9 to the 12 over 24, which we know reduces to 1/2, which then we also know that is in radical form the square root of 9, which is 3. So a lot of things to consider there. Okay, the next ones use rational exponents to simplify. We're going to change it to 2/4, which, if reduced, is 25 to the 1/2, and that's just saying the square root of 25, so your final answer is 5. Example 7, we're just going to take the 2 and divide them and reduce. A to the 1/2. And if it wants it in radical form, you're going to have to put the square root of a. So that's rational form, this is radical form. Just look at the directions to make sure you know. And then example 8, 2 to the 12 over 6. A to the 6 over 6. So that's 2 to the 2nd, a to the 1st, for a final answer of 4a. Now this is in square root form, and it starts with an even index there and an odd exponent. So 4, absolute value of a, would be your final answer. And then for the last couple here, this one we're writing as a single radical expression. So we're going to begin by putting them as a rational exponent. Rational, there's a 1 and a 2 here, so that's 1/2. And we are going to have to subtract them because it is division. And anytime we subtract fractions, we're going to have to get a common denominator. So I'm going to write that off to the side. This is 6, which would give that a 4. This is 6, and that's going to be a 3. So x to the 1/6 is going to be simplified. And then it says a single radical expression, so we cannot stop there. It'd be 6th root of x. And for the last example, we have everything to the 4th power. So what is going to happen is I'm going to ignore the 4 on the outside for just a little bit, okay? And I'm going to put 4 to all of my exponents and the roots, so it'd be 4 to the 1/2, a to the 1/2, b to the 2/2. Now, all of that is to the 4th, which means that I multiply each one of them together. So it would be 4 to the 4/2, a to the 4 halves, b to the 8 halves, because that's like 4 over 1. So then we have 4 squared, a squared, b to the 4th, and to simplify one last time would be 16a squared, b to the 4th, and that would be your final answer. So I hope you've enjoyed this lesson today, and I will conclude there.